This is your test 3 review. Number 1 says find the domain and range of the relation. The relation is 12, 1, 6, 6, 1, negative 4, 11, 5, and negative 9, negative 6. Okay. The domain is the set of all x values. So that's going to be 12, 6, 1, 11, negative 9. And the range is a set of all y values. So it's 1, 6, negative 4, 5, negative 6. Now they aren't in that order on the test, but you just rearrange those and you can see that that is C on your test. Number 2, find the domain of the function. So this function is a quadratic function because the highest power is x squared. And so the domain is the x values, or what can I plug in for the x values. Okay? So you can plug anything in. There's no denominator, there's no radical. So the domain of that function is all real numbers. Alright, now number 3, the same directions, find the domain. You can see here this has a denominator, and so we don't let denominators equal 0 because that would cause a problem. And so that's called a discontinuity whenever your denominator equals 0. So a negative 3 would make that equal 0. You can just look at it and tell. But if you want to work something out and tell, you just say x plus 3 equals 0. So that's what would make that 0. And so you see that number would be negative 3. So we want to leave that out of the domain. So the domain would be negative infinity to negative 3 union with negative 3 to infinity. And so that's a tricky way to leave a number out of the domain, by stopping an interval at that number and starting an interval at that number with parentheses. Okay. Problem number 4 says f of x equals 20 x squared minus 9x. G of x equals 9x minus 8. Find f of g of 10. Now, if it was f of g of x, I would just find f of g of x. I would take the g and I would plug it into the f. But since I want to find f of g of 10, there's a shortcut. What you can do is first plug the 10 into the g, and then whatever answer you get from the g, plug that into the f, and that'll be your answer. So that's what I'm going to do. I'm going to take the 10 and plug it into the g. So g of 10 is 9 times 10 minus 8. That's 90 minus 8, or 82. And so I want to take 82 and plug that into f. So f of 82 is going to be 20 times 82 squared minus 9 times 82. So obviously I'm going to need a calculator for that. 82 squared, we have to follow order of operations, so we have to do the exponents first. 82 times 82, and then say that times 20. Alright, so I have 134,480. And then that's going to be minus 9 times 82. So minus 738. Alright, so that is 133,742. Alright, number 5 says find the domain of the composite function f of g. So we need to find f of g and then find the domain of that. So f of x equals 6x plus 42. G of x equals x plus 1. So we're going to find f of g of x and then find the domain of that. So this means take the g and plug it into the f. So that's 6 times x plus 1 plus 42. So that's 6x plus 6 plus 42. Alright, so that's going to be 6x plus 48. Alright, and then the domain of that, what can I plug in for x? Anything. So the domain is all real numbers. Alright, number 6 says to evaluate the function at the given value. So I want to find f of x minus 1. So that means I need to plug in an x minus 1 for every x in parentheses. So make sure when you plug it in, you do put it in parentheses, because if you don't, that'll mess things up. Now, x minus 1 squared is not just x squared minus 1 squared. X minus 1 squared is x minus 1 times x minus 1. So that's going to be x squared minus x plus 1, or x squared minus 2x plus 1. Alright, and there's a 2 on the outside of that, so it's 2 times x squared minus 2x plus 1. So minus 2x plus 2 plus 3. So distribute this 2. You have 2x squared minus 4x plus 2 minus 2x plus 2 plus 3. Now combine your like terms and you'll have 2x squared minus 6x plus 7. Number 7 says to find and simplify the difference quotient, and it gives you the formula for the difference quotient. F of x plus h minus f of x all over h. Alright, so f of x is equal to 5x minus 7. So the first thing we want to do is find f of x plus h. So f of x plus h is going to be 5 times x plus h minus 7. So that's going to be 5x plus 5h minus 7. Now that's just the first part of the formula. That's f of x plus h. Alright, and so that's what I want to plug in right here in the formula. Sorry. So I'm going to plug that in. That's going to be 5x plus 5h minus 7. And now look at the next part of the formula. Minus f of x. So minus, and then I have to plug in my original function. My original function was 5x minus 7. And that's all over h. Alright. So I have 5x plus 5h minus 7. Distribute this negative, so I have minus 5x plus 7 all over h. Now some terms should cancel out. 5x, negative 5x, negative 7, positive 7. Alright, so 5h over h. So that's equal to 5. Alright. So that means that the average rate of change of that function is 5. Number 8 says determine whether the relation is a function. So we have the point negative 9, 2, negative 9, 3, negative 1, 7, 3, 6, and 8, 9. Now, the easiest way to tell if a relation is a function is by doing a mapping. So you list all the domain values in a vertical column. So that'll be negative 9. You don't repeat x values or y values if the x values are the same. So negative 9, negative 9, negative 1, 3, 8, and then that's the domain. Then the range is 2, 3, 7, 6, and 9. And now we do our mapping. And the way we do a mapping, we look at the ordered pair and we're going to draw an arrow from negative 9 to 2. Alright, we're going to draw an arrow from negative 9 to 3. And do the same thing for these 3 ordered pairs. Do a mapping from negative 1 to 7, a mapping from 3 to 6, and a mapping from 8 to 9. Now, we have one x value that goes to 2 different y values, or one element of the domain goes to 2 elements of the range. So that's not a function. If you would have had each x go to exactly 1 y, then it would have been a function, but it wasn't. Alright. Number 9 says use the graph to determine the function's domain and range. So you need to look at your graph on this one because I definitely can't draw a graph that pretty. Alright, remember that the domain is all the x values. And I'm just going to do a super rough sketch of this graph. It looks something like this. I'm not even going to put numbers here. And so, since this graph is going off of the actual graph drawn on the paper, you imagine there's arrows there. So this thing is going to go up and to the left forever and up and to the right forever. And so we could trace from the x-axis up to the graph everywhere if we extended this graph, forever in both directions. And so that means that the domain is going to be all real numbers. Now the range, remember that's the y values, so that's up and down. So the smallest y that we could take and trace over and touch the graph would be right here at the bottom. So we need to see what that bottom y is. Alright, looks like that's going to be negative 1. And since you can actually touch the graph, there's no hole there, you put a bracket with negative 1. Alright? And then you see you could touch the graph as you go up the x-axis forever. So that means that forever in the positive y direction, that's going to be infinity. So the domain is negative infinity to positive infinity. The range is negative 1 to positive infinity. Alright, number 10 says find f minus g. F of x equals 4x minus 6. G of x equals 7x minus 3. And find f minus g. So be careful when you're subtracting, because remember, if you subtract something, you have to put that whole something in parentheses. So this is 4x minus 6, and then minus my g, and I want to put it in parentheses so that I'll remember to subtract every term. So this is going to be 4x minus 6 minus 7x plus 3. Put your x's together, that's 11x. Now put your numbers, your constants together, negative 6 and positive 3 gives you a negative 3. So that's 11x minus 3. Number 11, f of x equals 9 minus 2x. G of x equals negative 7x plus... Oh, that's a negative 7, sorry. So if you're watching this video, thank you, class. So 4x and negative 7x, I guess I just put those together. Need more coffee. So negative 3x and then what? Minus 3. Alright. Alright, number 11 is f plus g. On this one, we don't have to worry about parentheses. So 9 minus 2x plus negative 7x plus 2, because you're adding, and so you don't have to worry about parentheses. So that's going to be negative 11x plus 11. Alright. Is that right? What did I do wrong? Yeah. Alright, so y'all are awake. So make sure you put together the right numbers. A lot of times what I like to do, especially if I'm working this slowly and not trying to work so fast, you know, if you have a pen or something, just like underline maybe some of your like terms, and that way you'll know which ones to put together. But if you try to do it fast like I'm doing, sometimes you'll make mistakes. So take your time is the moral of that story. Alright, so f times g. So f of x here is equal to 5x plus 9, and g of x is equal to 4x minus 3. So full that out, multiply this term times both of these terms, and then multiply this term times both of these terms. So that's going to be 20x squared minus 15x plus 36x minus 27. Alright, so that's going to equal 20x squared, and now positive 15x, or no, negative 15x and positive 36x is going to give you a positive 21x minus 27. Alright. Number 13, for the given functions f and g, find the indicated composition. This says find g of f of x. So this means take the f function and plug it into the g function. We're given that f of x equals negative 5x plus 3, and g of x equals 2x plus 2. So what I'm going to do is I'm going to take this f function, and in parentheses I'm going to plug it in right here in the g. So that's going to be 2 times negative 5x plus 3 plus 2. Don't forget this plus 2 at the end. It's very common to forget to put that in there. Alright, now distribute your 2. You have negative 10x plus 6 plus 2. So it's negative 10x plus 8. Alright. Number 14. F of x equals 3x plus 5 if x is less than 5, and negative 2x minus 4 if x is greater than or equal to 5. Alright, so it's all about what you're plugging in with a piecewise function. This problem says we want to find f of 7. So this number here will tell us which equation to use. So is 7 less than 5 or is 7 greater than or equal to 5? Of course it's greater than 5, right? So since 7 is greater than 5, we use this bottom equation and plug in a 7. So that's negative 2 times 7 minus 4. or negative 14 minus 4, which is negative 18. So don't plug the 7 into both equations. Just plug it into the one that whose condition it meets. Alright, number 15. Use the vertical line test to determine whether y is a function of x. So, is this a function is basically what it says. The vertical line test says if you can draw a vertical line and it touches the graph more than once, it's not a function. So that's not a function. Right. Number 16 says graph the function. Alright, so it's x squared minus 3. The easiest way to graph a function is either to make a table. If you know what x squared looks like, then you could use a transformation. Making a table is usually pretty quick. Just if you're making a table for a quadratic, you may want to put a few extra values there. Alright, and so you pick out the x values. So I'm going to say negative 3, negative 2, negative 1, 0, 1, 2, and 3. So if you plug these in, plug them in each separately. If I plug in a negative 3 here, I'll get positive 9 minus 3. That's 6. If I plug in a negative 2 here, I'll get positive 4 minus 3. That's 1. If I plug in a negative 1 here, I'll get 1 minus 3. That's negative 2. If I plug in a 0 here, I get negative 3. If I plug in a 1 here, I get negative 2. Plug in a 2, you get 4 minus 3 is 1. Plug in a 3, you get 9 minus 3 is 6. Alright, and so you can sketch that on the provided graph. Alright, and so negative 3, 6 is up here. Negative 2, 1 is right here. Negative 1, let me put some negatives here. Negative 1, negative 2 is right here. 0, negative 3 is right here. 1, negative 2 is here. 2, 1 is here. And 3, 6 is here. Alright, so it's going to be, and it's not perfect, but it's going to be a U-shaped graph opening upward that crosses right here at x equals negative 3. Alright, number 17 says, determine whether the given function is even, odd, or neither. So here's the given function, f of x equals x cubed minus 5x. To tell whether it's even, odd, or neither, you evaluate it at negative x and see what you get out. So this is going to be negative x cubed minus 5 times negative x. So that's going to be negative x times negative x times negative x, or negative x cubed, and then negative 5 times negative x gives you a plus 5x. Now, there's two ways to tell. Either you look at each term individually, and you'll be able to see that each term is opposite, so that tells you that it's an odd function. Or if you take what you get and you factor a negative out of it, so the negative of that would be x cubed minus 5x, then this right here in the parentheses has to be the same as this right here, and it is. Either way, it's an odd function. Okay. Number 18 says, determine whether the equation defines y as a function of x. Y squared equals 2x. So to do that, you solve for y. So to solve for y, I'd have to take the square root of both sides of the equation. When you do that, you have y equals plus or minus the square root of 2x. So when I plug in 1x, I get out 2 y's. That's not the case for 0, but like if I plugged in a 1 right here, my answer would be plus or minus the square root of 2. So plugging in 1x gives me 2 y's, so that's not a function. Okay. Number 19 is one of those with a graph, so you need to make sure that you look at that one. It says identify the intervals on where the function is changing as requested. Increasing. So it only wants to know where it's increasing. So start on the far left. And remember, when we write intervals on which a function is increasing, decreasing, or constant, they're intervals of the x. So we just use parentheses. Alright? So if you look on the far left, it looks like the graph is increasing from x equals negative 2 until you get to x equals negative 1. And then it goes constant, and then it decreases. But then at x equals 3, it starts increasing again. And it looks like it goes off the graph that's drawn, so that means forever. Alright? So these are the two intervals, and you don't put a u here or anything, but this and this interval are the two intervals on which the function is increasing. Alright, number 20 says, find the inverse of the one-to-one function. F of x equals 6x minus 1 over 7. Alright. So, step 1 to find the inverse is to let y equal f of x. So y equals 6x minus 1 all over 7. Step 2 is to interchange x and y. So x equals 6y minus 1 all over 7. Step 3 is to solve for y. So you have to get the y by itself. Well, this 7 on the bottom is stopping us from doing anything. So the first thing I need to do is multiply both sides of the equation by 7. And that's going to get rid of the 7 here. So I have 7x equals 6y minus 1. Now to solve for y, again, I want to get y by itself. I have a minus 1 here, so move that over. So I have 7x plus 1 equals 6y. Alright, and so to get the y by itself, I divide both sides by 6. When I do that, I have y by itself. The fourth step is to let f inverse of x equal y. So f inverse of x equals 7x plus 1 divided by 6. And that's your answer.